Okay, I will check your 2016 FRQs at the end of the class. We've been making progress through packet 6, so we've gone through a good chunk of the first 20 pages. So let's see if we can cover another 10 or so pages today. And then tomorrow I'll pick out problems from the remaining 30 pages or so for us to look through. Okay, so here's page 20. I want to go over number 11 here. Okay, so for x value between 0 and 6, the graph of f prime is a piecewise linear function. If f 0 equals 1, what is a maximum value of f on the interval? So maximum value, this is the derivative graph. Let's figure out where our relative max is first. So if this is our f prime graph. We can label accordingly: positive, negative slope, and on the x-axis is slope 0. So if I create my slope sign line, we see there's a critical point at 3. So at 3, to the left of 3, above the x-axis, so positive slope. To the right of 3, below the x-axis, and then at 5.5, the graph is going to go back to above the x-axis. So we know there's a relative max at 3. So we just have to figure out the location of the f of x at 3. So we're going to use final equals initial plus displacement. So f of 0 is 1. And then whatever the area is from 0 to 3, that's going to be our displacement. So we do 1/2 base times height. Okay, it's going to give us 3 as well, because 1/2 3 times 2. 2's cancel out. I'm left with 3. So 1 plus 3 equals 4. Okay, page 12. Sorry, number 12. We have a function given by y equals 9 to the x. If 4 subintervals of equal length are used, what is the value of the right Riemann sum approximation for 0 to 2? Now, this will be easier if we just had a table of values and we can just fill out, we can just uphold our width and height from our table of values. But in this case, we have to draw or gather this information on our own. So one thing is, without a calculator, we have to know what that 9 to the x looks like. You don't know in detail what it looks like, but you do know that it's an exponential function. So it'll be very much like an e to the x. So we can basically do a rough sketch of the graph. This is our e to the x, which all exponential functions look pretty much the same. Right Riemann sums from 0 to 2. So, but we do know we need 4 subintervals, right? So 1, 2, 3, 4. We want to end at 2, but you got to split 2 up into 4 even parts. So every interval is going to be 1/2, right? So 1/2 plus 1/2 is 1, plus 1/2 is 1.5, plus 1/2 is 2. So we want to attach every right endpoint to the curve and let that endpoint represent the height of each subinterval. So 1/2, we want to attach to the curve, drag that horizontal line over. That is a right-handed rectangle. And then 1 can be dragged over. That's also a right-handed rectangle. 3/2 over. That's also a right-handed rectangle. And finally, 2. So we know the width of each of our rectangles is going to be 1/2. But the height, we can just plug each of these endpoints to the function and get the y value that way. So So the integral from 0 to 2 of f of x dx, we're just going to add up a bunch of these rectangles here. So squiggly line. And the width of our first rectangle is 1/2. The height of our first rectangle is f of 1/2. So if I plug 1/2 into the function, I get 9 to the 1/2. So that's the height of my first rectangle. We just go down the line, repeat this process for each of our rectangles. 1/2. Second rectangle is connected at 1. So plug 1 in for x times 9 to the first power. Third rectangle, f of 3/2. 3/2 in for x. And then f of 2. So this is 1/2 times 3. That's square root of 9. 1/2 times 9. 9 to the first power is 9. 9 to 3/2, the same thing as square root of 9, which is 3. And 3 cubed is 27. And then 1/2 times 81. Now we do have to add this up by hand. Sometimes you may have some problems that require to do a little bit more calculation than others, but this ends up giving us, adding up, gets us 60. Okay, next up, page 21. Find the derivative of this function. You got that x plus 1 over x squared plus 1. So that is quotient rule, right? Numerator, denominator. So we just have to step through quotient rule here. F prime g minus f g prime all over g squared. So my top is f, my bottom is g. So f prime times g minus f times g prime all over g squared. We just have to keep an eye on our answer choices, and we can just stop whenever we're able to find a matching expression. Okay, next up, page 21, number 14. Reads, the velocity of a particle moving along the x-axis is given by v of t. If the particle is at x equals 4 when t equals 0, what's the position of the particle when t equals pi over 2? So this is a final position equals initial plus displacement. The only distinction here is we have to do this work this out by hand, and there is unit circle involvement here after we get everything lined up and had derivative found. So we're trying to find x of pi over 2. We have x of 0, which is 4, and then we want to bridge the gap between where we start and where we're going to end up, and our displacement is the integral of our velocity. Without a calculator, we got to go through u substitution. U value is 2t. Find the derivative. We'll get a 1/2. That's going to come out of it. Integral of sine of u is negative cosine of u. And then keep that negative 1/2 out in front. Bring back your original variable. You plug in your upper and lower bound. Pi over 2 in for t. Cosine of pi is -1. And then plug 0 in. Cosine of 0 is 1. And just have to work your way through, and it ends up giving us the displacement of 1. 4 plus 1 equals 5. Next up, the function y equals g of x is a differentiable and increasing function. On what interval is the function y equals g of x cubed minus 6x squared increasing? So anytime I see the word increase, decrease, I know it has to deal with slope. If it deals with slope, it's got to deal with the derivative. So I have to get to my derivative first. So my function starts off as g of x cubed minus 6x squared. It feels a little bit strange because this is in function notation, but hopefully we can see that, oh, there's a need for chain rule here if I want to find the derivative, because I know that chain rule is outside's derivative times inside's derivative. So I'm going to go ahead and go through chain rule and see what comes of it. So outside's derivative, we know g is going to turn into g prime times the inside's derivative. So x cubed minus 6x squared becomes 3x squared minus 12x. So now we know that it says g of x is differentiable and increasing, right? So if our g of x is increasing, that means g prime is always positive. So we actually don't have to worry about this. This is always going to be positive. So we should have to worry about creating critical points from a sign line from this information. So we can set this equal to 0. Because we want to find, basically we want to create our first derivative sign line, get our arrows to show up, and then we can see where our graph is going to be rising and falling. So we set 3x squared minus 12x equal to 0, factor out the 3x, and we get 0 and 4. Okay, for each subinterval, we can test with this derivative. I can plug -1 in. I'll get a negative value. Sorry, -1 will give me a positive value. Sorry. Don't have to worry about this, just have to worry about this 3x squared minus 12x. Plug 1 in, 3 minus 12 is negative. Plug 5 in, I'm going to get a positive value. So my graph is going to be increasing in these two intervals, -infinity to 0, and then from 4 to infinity. '16 is a little bit strange. We don't typically like, it's cumbersome to work with absolute values. So it's like, what do we do with this absolute value of x minus 3 over x minus 3? And also, it's not like we can plug in the calculator either. But what we can do is we can just look at the numerator first, right? What is that numerator telling us? So we know that absolute value of x minus 3 is the same thing as, right, if you look at the graph of x minus 3, there's a vertex at 3. We know to the left of 3, my slope is going to be negative. And then to the right of 3, it'll be a positive slope. So if I know that that's absolute value of x minus 3, then divided by x minus 3, I can just divide every expression by x minus 3 and see what results. We know that this is going to turn to be a -1 because x minus 3 is canceled out, except the negative. So it's really a graph that looks like y equals -1 to the left of 3. And then x minus 3 divided by x minus 3 is just 1. So the graph is going to be 1 to the right of 3. So if you look at what this could look like, it looks like this. Right? We have at 3, to the left of 3, it's y equals -1. That's just a horizontal line. And then to the right of 3, it's y equals 1, which is also a horizontal line. So this is what our graph looks like. So here we can say the limit doesn't exist at 3 because if we pick points on both sides of 3, our arrows are not in agreement. They're not headed to the same y value. So it does not exist. Next up, 17. Sometimes College Board, they like to insert problems that have these constants to see if that will throw you off. So just remember, your a value is just a number. So imagine this was like 3e to the -3x, right? How would you find the derivative? Same process. So f of x is equal to a times e to the -ax. So we know the derivative for e to the u is e to the u times u prime. So that's all we need. So remember, a is just a coefficient. So imagine this is like 3e to the negative 3x. The derivative would just be, we know the coefficient is going to stay. So it'd be ae to the negative ax, right? E to the u times u prime, and u prime for negative ax is just going to be negative a, right? If it was negative 3x, you'll make it negative 3. So negative ax will follow that same pattern times negative a. Multiply that together, we get negative a squared. Answer choice E. I'm going to skip some of the solving differential equations. I feel like we've been doing so much of those that we can probably skip them. I want to kind of highlight problems that that you may need help getting started with. Okay, so 18 differential equation, we can skip that, but basically it's cross multiplying and rearranging and seeing which step we can remove, or it can say it's incorrect. Number 19, for what value of the function is there a point of inflection? The only thing I want to point out is that we know our steps, right? We're going to set f double prime equal to 0. But we got to go further than this. If we find our critical points, that's not enough. We have to actually set that equal to 0 and find those critical points and populate your concavity sign line, and then make sure that you're actually spending the time to test each subinterval. And then you look at your signs, right? If there's no change in concavity, it's not a point of inflection. So here, even though -2 and 0 is going to end up giving you critical points, only -2 will end up giving you fill the condition of being a point of inflection, because there actually is a change in sign. Uh, 20 is just L'Hopital's rule problem. Yeah, so plug 2 in, you get 0 over 0, reevaluate, find the derivative, reevaluate again. Now get you down to a real number. All right, page 24, functions w, x, and wx, y, and wx and y are differentiable with respect to time. And we have w equals x squared y. If x is decreasing at a constant rate and y is increasing at a constant rate, what rate is changing with respect to time? So we have all these mentions of time. That should help remind us, oh, this is related rates. I got to define the derivative through the appropriate process, and I'm going to attach all these d over dt's along the way. So we should expect the dw dt to show up, a dx dt to show up, and dy dt to show up. So another thing to be aware of is these are being x squared and y are being multiplied. So we have to go through product rule, right? Okay, so x squared's derivative is 2x dx dt times the g function, which is y, plus back to f, and then g prime, y's derivative is 1 dy dx, dt, sorry, dy dt. So all the details that they give us about these values, we're looking for dw dt. We know that x is decreasing, so we know dx dt is a -1. We know y is increasing, so dy dt is a +4. And we're looking for dw dt. And then x is 6 and y is 20. So we have everything that we need to put into our derivative equation and then solve for dw dt. Sorry, 2/6 times -1 here as well. Um, 22, I think is pretty straightforward. We're just going to find f prime, f double prime using power rule, create your slope sign lines, create your concavity sign line, populate everything about the sign lines, and then read your sign lines to determine which interval is the graph. Is the graph going to be positive? At the same time, both decreasing and concave up. So once we line up our slope and concavity sign lines, we can tell that between -1/2 and 2, or between 1/2 and 2, we see both slope and concavity lined up in a way that presents both properties. Uh, 23, you guys saw something like this on your multiple choice test here, where we want to find f prime of -1, so we can find each of the derivatives and see if the derivatives are the same. And if the derivatives are the same, then we have a derivative. But if the derivatives are not in agreement, then therefore the limit doesn't exist. So here, for f prime of -1 doesn't exist if these are not in agreement. So this one, f prime of x of 3x plus 5, f prime of x will give us -3, and this one will give us a -2. So 3 and -2, they don't match up. The slopes are not the same, and therefore my graph is not going to be a smooth curve, so undefined. Okay, I'm going to skip to 26. 26, this is a page 25, is application of second theorem. So second theorem says take the derivative of an integral, which is going to go through this process. And I think with second theorem, I think we know to plug in that upper bound, but we forget that we have to multiply by the upper bound's derivative. So second fundamental theorem of calculus says the derivative definite integral from a to p of x of f of t equals f of p of x. I think most students are pretty good understanding that these two cancels out, the upper bound gets plugged in, but this is what we forget, that p prime is also living here because the derivative, even though it wipes out the integral, it still has an impact on that upper bound, and that's going to look like this times p prime. So if I want to do the derivative of definite integral from 1 to root x of 1 over 1 plus t squared. Okay, so the rule says take the upper bound, insert into the variable of the expression. So root x will insert itself into the t. But we have to remember, we got to do p prime. So p prime is the derivative of square root of x, which is x to the 1/2, and we got to do the power rule there. So that gives us times 1/2 x to the -1/2. Do some cleanup. Put the 2 in the denominator. Put the x square root of x in the denominator in the same space as that root as that 2 here, and then we just have it all multiplied together and share the same denominator here. So equals 1 over 1 plus x times 1 over 2 root x. It'll look like answer choice A. Okay, 27, here's an example of unit circle knowledge needed. Particle moves on a y-axis, x-axis. X of t is given by sine of 2 pi t plus 2 pi t. For what value is particle at rest? So that should indicate to us. So that's talking about motionless. So if there's something that's motionless, that means velocity is 0. So we have to find the velocity set equal to 0, and then from there we can solve for t. So to get to velocity, we have to go through chain rule. Sine of u becomes cosine of u times u prime. And 2 pi t becomes 2 pi. Set that equal to 0. And let's see what we can do to bring this up. If I subtract 2 pi from both sides here, divide both sides by 2 pi. So cosine of 2 pi t equals -1. Let me swap places here. So this requires an inverse trig here. If I want to solve for t, I'm going to rely on inverse trig to carry that cosine over to the other side. So 2 pi t is equal to inverse cosine of -1. So we ask ourselves, when is cosine equal to -1? Cosine equal to -1, unit circle wise is at pi, right? Cosine of pi is -1. So we know that 2 pi t is equal to pi. And then divide both sides by 2 pi. We can solve for t. T equals 1. The pi's will cancel out. Okay, let's move on to the calculator portion of this test. So page 7. Number 76, particle moves along a straight line. T is greater than 0. And which of the following gives the average velocity of the particle? So average velocity can look like this, right? Average velocity, maybe we're thinking average value theorem, which is true. But we don't see this option in our list, right? So how else can we think about average velocity? Well, average velocity is the change in position over change in time, right? So if I think of it that way, then change in position over change in time, I can do x of b minus x of a or b minus a, but in this case, they use s for position. So s of 8 minus s of 2 over 8 minus 2. $77 is just a plugging into your calculator, integral of sine of 1 over x squared plus 1. And insert all this into your calculator here. Or you can just do directly math 9. We know a point of inflection is a peak. Peak or valley off of our F prime graph. So 27, we're trying to find an F prime graph, but they tell us that it's increasing. So that means it has to all live above the x-axis, and there can only be one peak or valley. So answer choice A is going to be the only one where the entire graph is above, and it's only going to exhibit one relative max or one relative min. Okay, 79. This is an example of volume problem here. A vase has a shape obtained by revolving the curve y equals 2 plus sine of x from 0 to 5 over about the x-axis. What's the volume as we rotate about the x-axis? So if we were to put this into your calculator, it looks something like a curve like this, going from 0 to 5, rotating about the x-axis. We can tell that this is going to be this method because there's no gap between the graph and the x-axis, so all we need is one big radius. Top minus bottom. Radius is, my top is at the 2 plus sine of x. My bottom is sitting at the 0. Your formula for this method is pi big radius squared. Okay, and your balance is from 0 to 5. All this goes in your calculator. Looks like they multiplied the pi through the answer. So make sure that you multiple choice, you just have to look at however way the answer choice is defined. Sometimes the pi is left as part of the answer. Sometimes it's multiplied through. If it's multiplied through, make sure you multiply by 3.14. Okay, number 80. The table gives selected values of the function. The function is twice differentiable with the second derivative positive. Which of the following could be the value of f prime of 3? So we know that the slope is positive, right? 2.4, 3.6, 5.4. However, if the second derivative is positive, that means the slope is continually increasing. So why don't we just find the slope between the two endpoints? And then we know that our slope has to be continually increasing because it's concave up, right? So if I find the slope between these two endpoints, 3.6 minus 2.4 over 3 minus 1, this gives me a slope of 0.6. But then from 3 to 5, my slope is going to be 5.4 minus 3.6 over 5 minus 3. Again, this all calculator entry, I'll do this by hand, is 0.9. So if my slope is 0.6 and it goes to 0.9, it has to continually increase in slope. So if this is 0.6, then maybe it can be 0.7, then 0.8, then 0.9. But it can't break that pattern. It's got to continually increase in its slope. So 0.6 is not going to be good enough because it needs to continually increase since we have a continuous concave up here. 0.9 doesn't work. Anything more than 0.9 doesn't fit that pattern. The only thing that fits is 0.7. We know that we want f prime of 3 to be 0.7 so that every slope is going to continually increase. '81 is also this idea that final equals initial plus displacement. So we've seen a lot of that. Hopefully we can recognize the need for it and be able to apply it. Next up, 82, you're given an f prime graph. You know, above and below the x-axis is positive, right, or negative slope. X-intercept is your potential relative min, relative max, and then the peaks and valleys are your points of inflection. So if you can create your first and second derivative sine line, then everything is in front of you. And from there, we should be able to quickly identify what our appropriate choice is. So above and below the x-axis, my critical points are at -2, 2, and 6. So those go on to my slope sine line. I choose values in each subinterval: above, below, below, above. And then my points of inflection, -1, 2, and 6. So option choice A. I have one relative minimum. See, that's true. One relative max, that's true as well. And 3 points of inflection. We have 3 peaks and valleys, so 3 points of inflection. Next up, 83, we have integral expression, but each of the integral expression is has pieces of it that are defined. So if we can separate our integral into 2 smaller integrals, pull the coefficients out in front, and then find a substitution that we can make with an integral, and really just a substitution process here, trying to work that through and the only missing piece is that integral from 0 to 3. So to get that 0 to 3, we create a separate relationship here. We know that 0 to 3 is part of an equation that says if I want to do the full region from 0 to 6, I can say that it's 0 to 3 plus 3 to 6. If I can go through this process with the information that I have surrounding it, I can figure out my 0 to 3 area is 4. If I have 4, I can fit that in and make that substitution. So. Okay, 84, 85, let's see. 84 is average value theorem. So we just have to go through, set up our formula, and then the integral from 0 to 8. We have the areas, just have to make sure we adjust for the signs. Above the x-axis is going to give us positive displacement. Below it's going to give us a negative displacement. So 14 minus 16 plus 50, go through average value theorem, divide that by 8. 85 is total distance, so all that is calculator work. We do math 9, and then we do math number ABS to get our absolute value to show up around our expression, and then the calculator will give us total distance. Let me skip to page 80, problem 88. H of x is the integral from 0 to 2. Yeah, 0 to x. Which of the following represents the value of h of 2, h prime of 2 versus h double prime of 2? So let me write out all the relationships here. We know h of x is just the integral h prime is the derivative of this. We know this second theorem, the x will get inserted into the x times 1, but that times 1 won't do anything to it. So h prime is just f of x, and then h double prime, it's just one derivative down f prime. If we take all these values and evaluate the at 2, we know h of 2 is the integral from 0 to 2 of f of t. So from 0 to 2, that's definitely a positive number. So let's say that's equal to, I don't know, 3 or something. H prime of 2, we know that is a negative slope there. Oh, sorry, h prime of 2 is f of 2, so f of 2 is 0. And then finally, h double prime of 2 is f prime of 2. This is the f prime, this is the f graph. F prime is slope, so the slope of 2 is definitely less than 1, which is less than 0, which is negative. So you're comparing 3 with 0 with negative, put them in ascending order, option choice E. Right? Second derivative is going to be the negative value. Order pair is going to be the 0, and then the area is going to be positive. Okay, let me do one more here. Number 90. Particle moves along the line so that velocity is given by v of t. For what values is the speed of the particle increasing? So we know speed is increasing if the signs are the same, right? So either velocity and acceleration, both negative, or velocity, acceleration, both positive. Now, velocity is the graph we're looking at. So it needs to be either above the x-axis with a positive slope, or it needs to be below the x-axis with a negative slope, right? So all we do is we just sketch our graph and then look to see where is my graph going to be either both above the x-axis with above the x-axis means positive velocity, positive slope of velocity would mean my acceleration is or derivative over acceleration is positive. So I'm looking at this interval here and then also this interval here because the graph is this velocity is below the x-axis, negative velocity, negative slope. So negative slope is indicates acceleration is negative. So the signs are both negative here, both positive here. So we look at our, we go to our graph, we find our relative min. So you can kind of trace to that point, or you can do second trace minimum. Pick points on either side, find that relative min. Pick points on either side, find the relative max, and do second trace 0 to find that x-intercept. And once you find those points, then and you know what you're looking for, option choice E. Okay, so the remaining pages in this packet are miscellaneous problems that I pulled from AP Classroom. So I kind of organized it by units. So it starts off with limits, then it moves into derivatives, then it moves into curve sketching, then it moves into finding integrals and the moves to differential equation and volume area. I'll kind of pick problems from every category tomorrow between in the next 30 or so pages. And hopefully over the weekend, you can finish it. And if you're a senior, you can turn into me maybe that Monday after you take your exam. And if you're not a senior, you have until the end of the school year to finish all that. Let me come around and check your 2016 FAQs. I don't know if I'm going to see you anymore after today because I don't know what your schedule is, but what I also have up here is I have a help session. This is from the 2016 international test that College Board released. So it has a full FRQ, 6 problem, has a full AP exam. I have the packet and the key. This is not required. It's just extra practice. And also I'm going to use this as help session Sunday night. So Sunday nights, 7:30 to 9. I'll send out a link, a Teams link, like around 7 Sunday night if you want to join. But also record it. So after the session, it'll also be there on my website. So just I want to have something new and fresh. If you want to come, if you want to either do a full mock exam or if you want me to go through it with you. Okay, let me check your 2016. Just to the end of the packet here. Pick your phones. Finish those pages. Fill them all. Oh, yeah.
It's still very pushing. But